Hey, I'm Shane Varco, the Executive Director of the Dalgarno Institute. Welcome to our Dalgarno Institute's no-brainer resiliency building sessions. Hey, welcome back. This is part 2 of our thermostat and thermometer sections. It's becoming a thermostat, rewiring your mind and starting new habits. We're going to kick off this session with a short video clip about how stress impacts the brain. Really, really cool. Check this out.
Exercise actually reorganizes your brain, and that's really why we work out, right? So our brains look organized to potential mates. Anthony here for D News, and a new report from a team at Princeton University has found that when you exercise, your brain actually reorganizes itself to handle stress better. We've known for a while that exercise can help your mental health, but it's sort of been a mystery as to why. It almost contradicts physical findings. See, while previous psychological studies have shown that physically active people are less stressed, studies on the actual structure of the brain show that exercise promotes the growth of neurons in the ventral hippocampus, the area that regulates anxiety. And see, young neurons are usually more easily excitable than old ones, so really, exercising should give you more anxiety. So why doesn't it? In the study, the researchers took some super active mice and some super lazy mice and surprised them by dunking them into cold water. The brains of the two groups behaved differently. The lazy mice had an increase in what's called immediate early genes. These are these genes that get turned on instantly and short term when a neuron is fired. And the active mice didn't have those genes turn on, even though they had more excitable neurons. And it's because their brains released more of a neurotransmitter called GABA, which is known to keep the excitable bits of the brain in check. GABA probably sounds familiar to you if you watched my video about the sleep cycle, because it's an important part of getting your brain to chill out and get tired at the right times. Evolutionarily speaking, this is a pretty amazing thing, and here's why. Think about fight or flight instinct. If you're in better physical shape, your body doesn't need to go into overdrive to give you the strength you need to get out of trouble. You've already got it. But if you're in bad shape, your body wants to get you into the most worked up state it can so you have a better chance of getting out of trouble safely. Here in modern society, those old survival triggers can get activated by simple day-to-day stresses, especially since our lives are spent sitting down at work or school or home. Regular exercise could be a good way to get your brain better acclimated to the little stresses of everyday life. I've been making a point of getting more exercise lately, and it's definitely been helping me deal with everyday anxiety.
This session's quote of the moment is about habituation. Habituation is a process that not only the mind is involved with, but the biology of the brain and body follow. In whatever the direction the habit takes you, Andrew Murray called this the law of human nature. Now, the quote of the moment is this: know the law of human nature. Acts produce habits. Habits breed dispositions. Dispositions form the will, and the rightly formed will is character. Really important. Know the law of human nature. Acts produce habits. Habits breed dispositions. Dispositions form the will, and the rightly formed will is the character. And these are the people that make the difference in the world. Very important. So, one decision that will always diminish the best recipe, remember we've spoken about that in previous sessions, of you is drug use, both legal and illicit at this age. We're going to drill down into some more into the science on this, particularly around the brain and the various parts of the brain. This session is going to be a little bit more full on than perhaps some of the other ones. But hold on, guys, we'll get through this, and you can stop this video and work through it and discuss it as we go. So, the brain's limbic system has a lot to do with how our emotional and cognitive brain parts work on the way we learn and act and develop good habits or unhelpful and undermining habits. Two parts of the brain that are really, really, really important in this space are the amygdala and the hippocampus. The amygdala has to do with the emotional memories, more to do with emotional memory, and the hippocampus has more to do with cognitive memory. But these two tend to form a loop. Looking after these two parts of the brain are really, really important in helping you become a proactive and positive thermostat, not just another pinball thermometer. How the amygdala and the hippocampus are influenced and in turn influence you is really, really important. Your brain, but more importantly your mind, remember the mind is more than just the biology of the brain. That's what scientists are still grappling with. Its development has a physical aspect and interacts with you and your environment. So again, that byplay with environment, your brain, your mind, your emotions, are all interacting. Author and Harvard-educated Sean Achor said this: positive emotions bathe our brains with chemicals that not only make us feel good, but dial up the learning center of our brains to higher levels. Consequently, we think more quickly and creatively, become more skilled at complex analysis and problem solving, note that, and see and invent new ways of doing things. That's from a thing called the happiness advantage, the 7 principles of positive psychology that fuels success and performance at work. Consequently, just a quick add-in here, if you destroy the amygdala or you mess it up, and it creates a real mess of your behaviour and conduct. And of course, drug use facilitates that destruction quicker than anything else. Now that's a given, guys. You need to hear that and understand that. It's a given, but there's more that goes into this space. If the hippocampus gets destroyed, you can't take your short-term memory and convert it to long-term memory. So new memories don't last. However, the previous memories, experiences, behaviours, ideas, hurts, pain, bad habits are all still there, but you can't change them if the hippocampus is messed up. So these are really important factors. That's a little snapshot about what's important in this space. Keep moving forward. Now, use your executive function well, or you'll lose it. Again, the brain, the mind is a developing, growing organism. It's really important that maturation is done in the right way here. Now, the prefrontal cortex, fancy name of the part of the brain, is a big chunk in the front of the brain that sometimes is called the executive function part of the brain. This is part of the brain that gets more of a workout when you hit puberty, the second most important developmental phase of your brain. It controls processes like planning, self-control, problem solving, and consequently decision making. All part of helping you make choices as you develop your maturity, hopefully doing it in the right context. Check out this quick video on how the prefrontal cortex works.
The term prefrontal cortex, or PFC, can be used to refer generally to the part of the frontal lobe that is anterior to or in front of the motor cortex. Neuroscientists generally further divide the PFC into subregions, and while there is no clear consensus on what those subregions should be, some common demarcations include the dorsolateral, dorsomedial, ventrolateral, ventromedial, and orbitofrontal regions. The PFC makes up a substantial proportion of the entire brain, and thus is not surprisingly involved in a long list of functions, but it is most commonly associated with executive functions. There isn't a precise definition for the term executive functions, but it generally refers to processes that focus on controlling short-sighted behavior to be able to act with a goal in mind. This may include things like self-control, planning, decision-making, and problem-solving. Because these are complex cognitive functions, it is unlikely any one brain region is solely responsible for them, and more likely they depend on distributed networks of brain regions. Nevertheless, the PFC seems to play a critically important role in executive functions, a hypothesis supported by neuroimaging research and cases where the PFC was damaged and executive functions impaired. Although each of the subregions of the PFC is typically associated with slightly different aspects of cognition, we are not yet at the point where we can confidently assign specific roles to PFC subregions. Most evidence suggests that the executive functions of the PFC are accomplished due to the interaction of these subregions and their communication with other areas outside the PFC. One general model of PFC function is that it receives sensory information about the external world, uses that information to plan responses, and then communicates with other areas of the brain to enact a response, which might involve anything ranging from movement to simply a redirection of attention.
Now, remember, one of our key resiliency components of our bungee rope that we talked about, the 3 components of our bungee rope in our first couple of sessions, is problem solving. Now, if you start undermining and sabotaging this developing capacity at this vulnerable age, your teenage years, you really are stuffing up your chances on it for a number of different things, and you're really undermining your capacity and your agency to make really smart and productive and fruitful and lasting decisions that help you grow and become effective. The implications are clear. Resilience is closely aligned with whole of brain activation, but also compromised with stress-related small brain activation. Activation of what they call the HPA axis, which we'll look at next. Maximizing hippocampal wellness is directly linked to enhancing resilience. Now, this is really important. That part of the brain, the hippocampus, that deals specifically with memory. It's kind of like, it's a rough example, but it's kind of like your RAM of your brain computer. It holds the data in this place, and you can work with it and take bits out and add bits in. But if you wreck that RAM and you slow that RAM down, like with a computer, everything slows down and you can't process as quickly. Now, key aspects to maximizing the wellness or the well-being of your hippocampus include, get this, quality sleep, exercise, nutrition, and safety, feeling or being secure. We'll look more at that at another session, but we'll touch on that later on. Some fast facts. So get your journals out and jot these down. Number one, neural networks are moldable and not fixed. Number two, neural connections have the capacity to change the patterns of firing. Number three, the role, function, and development of the amygdala is a key component in the development of your resilience. In a nutshell, the hippocampus also seems to be a powerhouse to foster resilience. Number five, the study found the stronger the connection between the hippocampus and the prefrontal cortex, the more the activation of the stress response is controlled. So that's really, really important. And number six, it is well demonstrated in research that the environment changes the neural networks. So what you're immersed in and what you're engaged with does influence the development of this decision-making and resiliency process. We'll see you next time.